Okay, Barry, thanks very much indeed. Very good to be here with you. Really well organised day so far. Us, then tea, with the last talk of the day. Alexis has some nice pictures. I have no pictures, but I do have some partial regression analyses and some p-values. I have no pictures of young children, so it's going to be great. Okay. Done also work with Thumjin Mujtaba and Joe Pearce, but Alexis and I are just talking about a subsection of a larger project. And the context is that it's part of a TWCF-funded project called The New Biology, and this is the education component. There are other components too. And one of the things we did that I'm going to talk about before handing over to Alexis is we developed a new instrument to try and measure more validly than number 4, secondary school students' attitudes to science and religion. Then Alexis, in the middle sort of 10 minutes, is going to talk about the RE lessons, and then I'll just very briefly mention a tiny bit about the science lessons, and then there'll be time for either questions or going straight into coffee, whatever you think fits best. So, attitudes to science and religion instrument. There have been quite a lot of these instruments, in other words, questionnaires, surveys in the past, but there hasn't been any real serious attempt to do what psychologists, psychometricians would regard as valid construct, design and testing and analysis. So we had a pilot study, which had just over 1,000 students in it, and we got an international advisory group to comment on our draft questions, and then you get an instrument, which is a survey, which you use in your main phase. It's got what are called constructs. It's got 17 of them. So just to give an example, it's got things like how students view the relationship between science and religion. It's got various psychological measures about the students, which I'll come on to later. Things like, are they good at critical skills? Are they competitive? And various things to do with how they view lessons. And the sample size in this main study is about the same, 1,102. And basically, it's tick boxes. So Likert scale, a few free response as well. These are year 9 or year 10, and there are 18 schools in the main phase. That's not the pilot phase, the main study. So in a talk of this duration, all I'm going to do is tell you of one finding. Can I make it clear? This is before the lessons that Alexis and I are responsible for have been taught. So this is a sort of background data. Not claiming formal representativeness, but reasonably large sample size, and you'll notice we don't ever quote something like 20% of students say this, because that's never valid unless you're confident you have a nationally representative sample. Ours is done through correlations, which are therefore much more valid whether or not a sample is representative. Right, so what we're looking to see is what correlates with students who consider that science and religion are compatible. There are 6 items in that construct, some of them negatively marked, some positively marked. So here are the items. Science explains things in one way, religion explains them in another. That's obviously reverse marked. In other words, somebody who very strongly agrees with that is classified as not considering that science and religion are compatible. You may start immediately disagreeing with that, but can I explain? This is done by factor analysis, confirmatory factor analysis, so it's the way of statistically putting together responses in a way that makes the most statistical sense of explaining the variation in the data. So as I said, it sits entirely within a standard psychometric, psychological approach to construct validation. Religion and science both explain the origin of the world in different ways. Again, that's reverse marked. Evolution is God's way of bringing species into existence. That's positively marked. I believe science and religion are compatible. Well, that fairly obviously is a positive one. My family believes science and religion are compatible. And it's possible to believe in God and still hold the view that life on Earth, including human life, evolved over time as a result of natural selection. Haven't got enough time to go into all the details of the composition. Majority of students self-identify as being secular, atheist, agnostic. Quite large numbers of Muslim students, quite large numbers of students who identify as being Christian, much smaller numbers of the other major religions. This is my last slide before I hand over. So remember, this is what correlates with saying, yeah, I reckon, as a 14-year-old, science and religion are compatible. It's partial regression analysis, so the order I'm going to give you is the highest correlations, and then we just go through, and I'll give you 10 in order. So what correlates most highly? There are about 90 other questions in the questionnaire. Students who think that science and religion are compatible are very positive about the value of science in improving the world. They're very positive about the value of science to society. They have a high awareness of environmental issues. They score well on measures of critical thinking. They are extrinsically motivated about science. That means they think that if you do science beyond school, it'll help you in your career or your job. They are positive about believing in the existence of God. They are interested in continuing to do science. They think their science lessons are basically pretty good. They're more positive than the students who think that science and religion are not compatible. They see themselves positively in regards to how they think they can do in the future in science. That's science self-concept. And the last one, they're actually quite competitive, which probably also correlates with being reasonably independently minded. So all I'll say is that does not fit very well with a conflict thesis model between science and religion. And just to remind you, these are a reasonable number, 1,000 students of this age, before any intervention in 18 schools deliberately selected to be fairly typical but different across England. So for me, that's both quite interesting and quite encouraging and slightly different to the story one often gets.
I should explain about the lessons. So thank you, Michael. So the intervention was that the sample of students were taught RE lessons and science lessons, specifically, at the same time, simultaneously, throughout a term, in no particular order. It was deliberately loose so that it wasn't too onerous on teachers. And then the research was either side of that intervention. So these are the RE lessons. They have, within their 6 lessons, and they have an introduction and plenary of the whole thing, if you will, so it sort of allows some reflection on the whole process. We wanted to encourage the opportunity for reflection. We wanted to encourage lots of empathy amongst the student body and religious literacy, philosophical literacy, ethical literacy at all opportune moments. Sorry, I'm speeding ahead there. So the nature of the actual lessons themselves were very social, so we could have as much interaction as possible. The stimulus that we chose, the stimuli we chose, we wanted to draw on a little bit of these historical controversies as well as current ones, and move beyond the conflict model that has been mentioned so much today, and to see that these debates are enduring and they're poignant. We wanted to give the opportunity for personal reflection as well as dialogue, because as you all know, it can be so common to sort of lose your own opportunity to reflect on your own thoughts, what you bring to it, and then to give the students as well the opportunity to be aware of what they bring, their own biases, their own subjectivity, in other words, reflexivity. So the social dimension was very key. And we wanted to make the point that our view is that the subjects don't interact in and of themselves, it's the people who allow them to interact, so that this is what we were trying to do with these lessons. So our first lesson was to just introduce the concept of 2 windows, so religion and science. And we started with Professor Dyson's statement here on accepting his prize. Science and religion are two windows that people look through, trying to understand the big universe outside, trying to understand why we are here. Expecting the possibility that students hadn't thought of science and religion in that non-conflicting way. So then they were asked to present a diagram to explain their own definition of science, then their definition of religion, and then to see the ways that they fit together and also the ways that they possibly don't. This is working like a robot right now, which is rather exciting. Does it have its own mind? Is it hearing me? I'm not sure. It appears not. I shall talk to it in a moment. The reason for this is that if we sort of get out of that analytical, answering questions mindset, although Reiss sits within such an evaluation-focused framework, if we work quite closely with art, we thought we might sort of elicit less conformist attitudes to this debate. So, upon doing that, sharing their diagrams, their understandings, then they would come back and they would understand what these questions present us. What can we know through science, if anything? What can we know through religion, if anything? So this kind of sets the tone of the whole series of lessons. And then lastly, the view that both views are one-sided, neither is complete, and they leave out essential features of the world. And then the final question was to ask the children, what do we think Dyson thinks about religion and about science? So they're sort of going beyond it, beyond the statements. They're thinking in much broader terms. So moving ahead to this, the next lesson, which was lesson 3, these are just the highlights. We looked at the famous weighing of the soul experiment. Has anyone done this in RE yet? No one. Wonderful. So he weighs the soul. He does it with a human. He does it with a dog. But the question is, it doesn't tell us what the soul is. It tells us something of its substance, of its nature. I'm so sorry about this. So in watching the video of McDougall explaining about the weighing of the soul, the children are then asked, is this a good way to measure the soul? So what is the soul? You know, is it something that could be measured scientifically? They then go on to look at various forms of evidence, and it's a marketplace. So this was positioned around the room. There's lots of interaction. We're looking at what Pam Reynolds says about her near-death experience. We're looking at Plato, John Hick, Abrahamic religions, Dharmic religions, Crick, Buddhism, the idea that there is no soul. I'm sure you're familiar with all these views. And then they'll then go on and then consolidate it into a table and compare what do they decide, what do they think is convincing criteria, really, and a good argument. So, having examined these different views and referred to their own view of what they think the soul is, we're thinking about moving towards much more religious literacy, really, including understanding of why certain perspectives, why certain views will describe the soul in a certain way. But the most important is the plenary of this section, so that they will be, thank you, Michael, so that they will be thinking about what it is that they think as part of this process. And so moving on to the next one, please. Michael, thank you. So lesson 4 would be the ethics of cloning. We're going to hopefully wow you with something. Yes, please. Great. So we start with something quite basic. When does life begin? They're asking these questions. They're sharing them. They're moving on. Who decides this? What decides this? What's the authority? So they're constructing meaning together, but they're also aware of diversity as a group. That's really, really important. So we've got this empathy, literacy building here. So having established this, we then go to this painting. Hands up if you've seen this painting before. Brilliant. So you know, for those of you who don't know, it's the period of time is the scientific revolution. Middle-class families would have a scientist come and visit their house and show how oxygen can be removed from a chamber, and it would usually be a mouse or something like this. But in this dramatic scene, Joseph Wright has shown a bird that we're drawn to for its innocence, its beauty. And we see here, it's quite obvious that the scientist is in charge here. And the faces all around represent different attitudes to what's going on here. So this is quite a different way of addressing this. It's quite dramatic. We'd ask them to sort of take on the scenes, the expressions, be hot-seated by their colleagues, that kind of thing. And then to ask who would they be in this situation? How would they feel? And then, next one, please. Thank you, Michael. And then the next one would be to look in much more detail at the possibility here of, say, one person on the surface, what does he think? And the children might come up with something like this. Now they can see that the science is real, life isn't a mystery, and then to invite the opportunity for them to think what's happening underneath that statement. So we may say one thing and yet think something different. What are the implications of that? And to extend that for all the characters as well. So, and then as a teacher, to extend that to peer pressure, to the problems with co-construction as well of ideas. And then perhaps for the next one, for your more abstract and children who relate more intimately with symbolism, you can look at the moon. And the moon is a very ambiguous item in the picture, detail in the picture. The moon might represent, for example, the light of God, the light of science, wisdom, something natural or something external. There's obviously no right or wrong here. And focus on the word might, of course. And equally, then you can highlight the fact that the clouds could be concealing or revealing. So this significant point in time is very key, okay, to the painter. And then we move on to look at cloning. Okay, so we look at Dolly the sheep. Look at a reliable video of Dolly the sheep reporting on experts responding to what was going on, the pros, the cons, the issues that are raised. And then we would present them with statements from different religions and humanist perspectives, such as the soul is born and unfolds in a body with dreams and desires and the food of life. From Hinduism or a Muslim view, he is the one who shapes you in the womb as he pleases. Okay, so a variety, for example, are given to children in groups, and they then try and understand what that statement would mean in the context of cloning. And then, having established that, they come back to the painting and say, who would hold that view and why? So we're just developing this literacy for something that's topical and for something that is, of course, is historical, but much more emotionally laden. And then to ask them who they would be, of course, in that situation. And we're nearly there. Thank you, Michael. The next one, please. Thank you. So then, finally, the penultimate one would be to think about what the advantages and disadvantages are to having a scientific or religious worldview, and the question of whether it's possible to have both at the same time. This lesson kind of explores the difference between knowledge and belief and asks the children, when did you believe in Father Christmas? When did that change? Who was the authority? When you knew Father Christmas existed, what were the effects that changed that view? So they're looking at their own sort of inner authority about what they deem to be true. And then finally, the last lesson is a reflection on the whole sequence, in which they're asked what's the relationship between science and religion. And they chart through a presentation, dramatic sort of construction with colleagues, as well as something on their own, to show how their views have changed. And then to move on to ask the question, does this matter? And perhaps the most important, what does this mean? What does this mean? Thank you.
Thank you. One of the nice things about working with Alexis is she also works part-time in the National Gallery, so we've managed to have team meetings over tea in the restaurant in the Sainsbury's wing of the National Gallery. I've only got 2 slides about the biology. The biology lessons, in some respects, look much less exciting, I think, than the RE lessons. And part of the reason for this is all we're trying to do is to shift some of the learning of the students to seeing biology to be a bit less reductionist. So just to give you 2 quick examples, the aim of the very first biology lesson that the students had was to get them to realize that while we're used to thinking nowadays about the fact that there's a close relationship between the genes an organism has, its genotype and its phenotype, of course, for every multicellular organism like ourselves or a worm or anything, the great majority of the various cell types it has the same genes, and yet the cell types look very, very different. So that's a very gentle, simple way of getting students to start to think that there isn't quite the equation between genes and appearance that the popular media and some school biology textbooks might have led them to suppose. It's utterly mainstream biology. And only to give you one more example, this is one of the more fanciful ones in a sense, a bit further ahead in this series, number 5. It's to do with, do we have free will, or are all our actions and thoughts determined? And we suggest teachers use a short video clip from The Truman Show. I don't know how many of you know that film. It's one of my favourite films. It's just so true to life. You know, or The Matrix, which is much better known. Possibly not so much by today's students now, but basically it's better known. So the question is, how do we know that the world is real and not just a computer program, a film, or game? By the way, I realise it could still be a computer program, a film, or a game, and it might be real for the characters inside, but this is 14-year-olds, so we're not trying to push too far, and it's basically a science lesson still, okay? Not an introduction to sort of, you know, French post-structuralist thought. What we're trying to get them to think about is, look, what you learn in ordinary school biology about genetics and hormones and the nervous system, is that compatible or not? And I mean that in the everyday sense of the term. Again, this is not some philosophical position to do with compatibilism or anything like that. The everyday sense of the term, is that compatible with free will or not? So it's trying to stick with mainstream biology, bits to do with hormones, genetics, but just push them towards a slightly less reductionist point of view. The only thing I'll say is that now all the lessons are on a website, so if any of you are interested, please get hold of either Alexis or myself at tea, and either get our email addresses if you haven't got them, or give us a card or scribble down your email address if you want us to give reference to them. And similarly, the questionnaire is now publicly available and can be used by anybody else if you're interested in using it in a range of settings. It's probably best for sort of, you know, 14 to 18-year-olds, but it might work very well with older people as well. Thank you very much indeed, Barry.